Hello, everyone, and welcome to this tutorial, which we've called Unlocking the Power of SNOMED Strategies for Quality Information Exchange in Healthcare. And this session was actually inspired by the overall theme of this Expo, which is Global Terminology Enabling Quality Information Exchange. So we thought it was a good spot to have a tutorial focusing on information exchange here. And I'll just invite Alejandro to come up here and say hi as well. So hello, I'm Højen. I'm a member of the implementation support team at SNOMED International. And I'm doing this together with my colleague Alejandro.
Alejandro Lopez Osornio, colleague of Anna in the implementation support team.
So we have designed this tutorial, and we hope that from this you'll get some good points of reference for best practice principles for data exchange with SNOMED. So when I started to learn about SNOMED CT, it was really all about you had to use SNOMED because that was really an enabler for semantic interoperability. Remember, and that was in the beginning of the 2000s, everyone talked about semantic interoperability. So I thought it was a good place to look back at that and look at what is the definition really on interoperability. So we took the HIMSS definition, and it's long, as you can see it here. So let's just highlight some of the points that is very relevant for the things that we're talking about here today. So interoperability is the ability of different information systems, devices, applications to access, exchange, integrate, and cooperatively use data in a coordinated manner within and across organizational, regional, and national boundaries to provide timely and seamless portability of information and optimize the health of individuals and populations globally. Wow, that's a bit of a mouthful. But in essence, as you can see in the green part of this, to establish or to optimize health of individuals and populations, we need interoperability. And part of that is around exchange. Seamless exchange across boundaries to provide timely and seamless exchange of information. So the objective of this tutorial is to see what are the principles for using SNOMED CT to achieve this. The overall motivation for interoperability are many. For example, improve business processes, care coordination, patient safety, value-based and high-quality care. So if we start over with the care coordination, well, in order for different physicians that meet a patient throughout a patient journey to be able to effectively communicate and discuss a patient situation, you need to be able to also share the information between them. And in today's world, where it can be different clinics, different places physically, it's just past the time of people running around with these paper-based records from one department to another. So in that is one of the drivers for data exchange, that we need to be able to provide information to the colleagues that are treating patients. And it relates somewhat to the improved business processes. But improved business processes also speaks to the range of different stakeholders that use clinical data, whether it be physicians or health administrators, whether it's for data analytics, reimbursement. So for those types of purposes, and to make data accessible to these various stakeholders, that is important to improve business processes. Patient safety, the accessibility of information is crucial for the clinicians to be able to make the right decisions about the care and treatment of a patient. So that's also a huge driver. And as we move on, focusing on value-based, high quality care, and value-based care is where it's not about quantity, it's about the quality of the care. So it's not about how much we are doing, it's actually about looking holistically at this patient with all the various types of information surrounding this patient. So to be able to provide value-based care, we also need to be able to have access to information And to have access to information, we need to be able to share and exchange information. And I'm sure this is all, have been working in this field, all of this. I know you know it, but even though we know it, it's always good to just take a step back and remind ourselves, why is it we do this? And why is it we are here in a conference as big as Expo is, all talking about terminologies and what we can do with it? This is why. Some of the scenarios for data exchange, there are quite many, and I'm sorry for those that I have omitted here, but I'll try to walk through them. So between healthcare providers that need to be able to look at and review what each other have found, for example, for diagnostic procedures and test results and so forth. So information about healthcare providers. If a patient is transferred between organizations, information to pharmacies about the medication prescriptions for a patient, laboratories that needs to make a test of a specimen and come back with some evaluation result. Public health agency who are doing population analytics to try to monitor the trends of a population, research institutions that try to derive knowledge from all the data that is being captured, for telemedicine, for social care, for people at home, that telemedicine is huge. And for that, data exchange is essential. Health insurance providers that needs to have access to information about what has happened to these patients in order to determine the level of insurance. And for patients to have access to information. I live in Denmark, and as soon as if I had like a blood test done, I would go into my app and I will see what has happened and what the results are. And so that accessibility to empower patients to really have health literacy is important as well. And health information exchange platforms are drivers as well, or scenarios where you want to have efficient ways of exchanging data across organizations. So all of these scenarios, these motivations is really to set the background for this session. So in the previous tutorial we just had, we talked about why information model and terminologies are important, because they are part of standardizing health records. So that goes for the same for information exchange. You can't achieve information exchange without standardization. Standards are essential to support the interoperability, consistency, scalability, efficiency, compliance to regulations, innovation, communication, data quality, and risk reduction. Standards are essential to have a common ground to achieve all of these. And SNOMED is one of those standards, one of them. There are so many that are important to enable data exchange. But SNOMED actually plays a role in all of these matters because it's a common language for health, and common is essential there, that it provides a reference point, something that can be used across various models, across various types of we just spoke about the range of different information model. There's a range of different systems applying different models, and SNOMED is a common language for all of these systems. SNOMED allows healthcare professionals and the systems to be consistent and accurate when they code and exchange information. And very importantly, SNOMED ensures that data can be interpreted. SNOMED is a semantic foundation for our clinical system. Meaning is really a buzzword for SNOMED. It's all about the meaning. When we have all the concepts, we define them, we say what are the properties of this clinical idea, and we try to be explicit about it so that computers and machines can make sense of the data that is being captured. But as I said, SNOMED is not the solution to everything. It's just a piece of the puzzle, because we need other standards and we need the standards to work together. That's why an organization such as SNOMED International have a really strong collaboration stream where we try to collaborate with other standards development bodies so that we can create a good and harmonized approach to, in this case, data exchange. So for example, the SNOMED on Fire working group is an example of that, where we tried to specify some general principles for using SNOMED with fire. But there are also other standards that are required. For example, the other domains, for example, administrative, financial, operational aspects that are not covered by SNOMED, you would need other standards for that. Non-clinical data that is also relevant to capture and also to include when it comes to, and may also be important for patient or precision medicine, where you need to include all range of factors and things that are outside the scope of SNOMED, and other standards and protocols to ensure the technological implementation of this. So for the next part of this tutorial, we are going to talk about approaches to information exchange with SNOMED. So this is like, you'll see this throughout these examples that we'll show you. Have two organizations, it can be countries, it can be hospitals, it can be whatever, that are trying to share information using SNOMED. So we're going to look at if you have captured pre-coordinated concepts in your records, how you share them, what are the principles? If you're working with post-coordinated expressions, what do you do then? With SNOMED, that comes with such a robust versioning mechanism, and we release a new version of SNOMED every month, and we have extensions and countries that makes modifications. How can we even do data exchange effectively? We're going to look a bit on that as well. And we're going to look at how you need your information model to achieve good and high quality data exchange. Let's just start with the pre-coordinated concepts. That's like the most simplistic way we can look at this. So imagine that in one system you have recorded that a patient has a bacterial infectious disease. So although the clinician, this comes from our UI demo, and I'm sure some of you have already seen this, but in this UI demo, you don't see the actual codes, but behind the scenes, what it's stored is the concept identifier. But the scenario here is that a pre-coordinated concept has been recorded. It's passed on to another organization, and in that organization, they are able to take the information shared and understand that this patient has a bacterial infectious disease. So they need to understand this pre-coordinated concept. The principles for that, or best practice principles, is that if you know about SNOMED design, you know that we have identifiers everywhere. Release file full of identifiers. When you exchange SNOMED pre-coordinated content, it's not the description identifiers that you should share. It's the concept identifier. The concept identifier is the anchor for the meaning of the concept. So always use the concept identifier. That's also the recommendation we give for storage. So in this system, they have stored using the concept identifier. They may have additionally stored the description identifier that was used and the term that as it was displayed and so forth. But they have the concept identifier, and that is what they use for sharing, because that will forever represent that meaning. Then when you share a code, in order for the receiver, we are aware that when you work in healthcare, it's not, even though SNOMED is a common language, it's also the hub between other code systems. So one thing that is important to share when you share information in general is also to tell what code system does this code come from. And here we have the URI specification. So SNOMED International has specified a URI for how we can refer to editions, versions, and derivatives using a standard format using URIs. And the URI you see here is the URI you would use generally to say this is SNOMED. And go into the URI specification, you can also see how you would refer to a version, an edition, and so forth. So these two are like the base. You need to include that every time you share information or share a SNOMED code, the concept identifier, and the URI for the code system.
And the code system is really important because if you need to know in which edition you are looking at. If you have a national extension and you're sharing a code that is only known in your national extension, you need to provide some way to the receiver to know that you're using that the code is part of that extension. So
Yeah.
Anna will explain that. but
Right here, you
it's
see,
key.
right here, it's just, this is the URI we refer to, we use to refer to the default edition of SNOMED that is on the server. In some of the later slides where I show exchange between editions, you'll see how the URI is different there. That the URI will actually refer that this is specifically if it's the Dutch edition or if it's the Danish edition. So I'll make note of that then. The last thing to also say is in some contexts, you can specify the version of SNOMED that is being applied at different levels. You could use it within each of the data elements, but often it would be something that is in the metadata of your communication message. So here you have URI, the URI for version. So to say that this information was captured using a specific version. And it's actually also an example of, if we take everything before version here, that refers to an edition. And this is like the core module. So it's the international edition that we're referring to. And it's the version, what have I said here? 2021, July 2021 version of the international edition. So all components in SNOMED belong to a module, and the module tells us who are the current owners of this component. And that's why it's the module ID that we use, because these modules, we also specify dependencies between this module. So by providing the module identifier, a system will be able to look into the module dependency and see what are the modules that are included here to find out what content am I referring to. But the details of that is for another session. So here is an example of a FHIR codable concept populated with a pre-coordinated concept. So here's the problem is a bacterial infection. And this is the XML representation for the condition resource in FHIR. And just to look into let me just try to click, yeah. So now if you look here, there is the code. So this is the code for the condition. And that includes a coding. And within that coding, we are able to specify the value here, or the code system. So the blue thing is the system, and that's where you see the URI for SNOMED. You can specify the version, and you can specify the actual value, and you can know the code, and you can specify the display term, and you can then also have the text. So that could be the preferred term that is applied on the server. So that would be how it would look in a FHIR condition resource. And it's under code where you see the code and the system, those details that I just showed you. When you look, and if you work with FHIR, you'll see that it's not always that you would actually include the version here. So that was like the overall principles for the pre-coordinated concepts. So let's look into something that a bit more complex. There are sessions throughout the Expo that are talking about post-coordination, and more organizations work with post-coordination. So it's good to have these principles established for how do we then share them. So post-coordinated expression is like a string as you would see it here. It's a composition where we compose SNOMED identifiers to represent a clinical meaning, not by a single identifier, but by a range of identifiers. And we use this syntax, specific syntax to represent certain areas of the meaning. So here we have an expression that represents the meaning fracture of the left tibia. And similarly to the scenario we had before, the objective is that the receiving organization will understand that the patient has a fracture of the left tibia. With post-coordinated expressions, and last year, was it last year? I think we had a whole tutorial on post-coordination. So I encourage you to go in and look at some of the presentations we have on post-coordination, because this is very brief, just explaining that there are different options for how you share post-coordinated expressions, and I've outlined them here. One option is that you can exchange the terse expression. So that's the terse expression would be the string as you see it here. So just exchange that instead of just a single code, you share all of this. Another option is that instead of taking all the different parts of your expression, you decompose the expression into separate fields. And the last approach we have here is that you exchange an expression identifier. There's a big caveat here that you need to only use that approach if you have a shared expression repositories where you have an agreed convention for how you access and how you use these expression identifiers. So this is if you have an expression repositories where you have auto-generated identifiers. This is an example of how it would look in a file resource if you have the terse expression and you share that. So similar example as before where we have the code. Now it's just a JSON representation, but essentially it's the exact same resource we're looking at. And under coding, we have the system, we have the code. And here we can see instead of just a single pre-coordinated concept identifier that I showed you just before, we now have the full expression here. And we have the display term that were the thing that was displayed for the clinician. But then there was also the terms as it has been decomposed from or extracted from the actual expression using the terms that are associated with each concept included in the expression. So that was the first approach where you took the terse expression. The second approach where you decompose the meaning. I wanted to keep to this condition resource, so that's why I've chosen a different example of an expression here to demonstrate or to give an example where I can use both code and body side. So here we have an expression that says, well, it's a fracture of bone with a finding side bone structure of left tibia. So essentially I'm saying it's a fracture of the left tibia. And that can be decomposed into a condition that is fracture of bone with a body side bone structure of left tibia. And here you can see I use two data elements in the message to populate the code for the condition and a code for the body side. So here, the finding side that is part of my expression is actually not shared because that's implicit in the information model. So I don't need that because the information model defines that if you have this condition, it can have a body side, but you extract the actual body side from the value used here in your expression. This then shows the third approach where you have an expression identifier. And again, a prerequisite for this is that you have a terminology server with an expression repository. So once you have created a range of expressions in your system, they are stored and they are identified. Some systems have a limitation in terms of how long, because expressions can be very long, and maybe your system or model has a limitation of how long identifiers you can hold. So that would be a reason for using an expression repository, so that you can give it an ID that has an acceptable length. And then that's the ID. But of course, you need to agree on how do you find out what expression lies behind this identifier. So that is something you need in the community where you share this information to have a common understanding of how you derive what this identifier refers to. And that's what this bubble here says.
There's an interesting thing there that while creating the guide and the specification for post-coordination, it was proposed that we create a new partition ID that identifies expression. That's the 6 that we see there, right? So the system can look at the concept ID and realize that it's actually not the concept ID, but an expression ID. And they need to look at that in the expression repository instead of looking at it in the terminology.
So if you represent one of these organizations that work with post-coordination, I encourage you to go in and read. I'll just say out the URL. It's not available on the slides here, but it's snomed.org/post-coordination. In this guide, you'll go directly to the guide if you go there, SNOMED.org/post coordination. And then all this idea with an expression repository and how that would work is documented there. So you're welcome to look at that and also reach out to us if you have questions to that specifically. So that is so now we've been through approaches for sharing pre-coordinated concepts and post-coordinated expressions. And let's now increase the complexity to talk about versions and editions. Let's start with versions. As I said before, SNOMED is updated regularly. It's very likely that systems apply different versions. It's very likely because we have new versions of SNOMED every month. And our members, they also produce extensions. Some are also up to every month, but otherwise once or twice a year. So knowing what version you're using is important also to be able to resolve things that issues that occur as you exchange information. So here is the scenario where we are exchanging information from an organization that applies the September 23 version of the international edition, forwarding information to another organization that uses the January 2021 version. So here is an example where you can see that we are using the version URI here. So we are sharing this code, heart valve disorder. So the code is here, this is the term. And in order for the terminology server in the other end of this channel to be able to know where does this code come from, we will look at the system. And what version of the code system are we looking at? We're looking at the international edition. We can see that on the module ID, and it's the September 2023. So from a message structure as this, the receiver will be able to derive, okay, they have applied a more recent version than us, and they will know that, well, it is the same edition. So we're using the same edition, but they use a more recent version. And when we do this, there is a risk that the concept may not be available in our system, because what if it's something that has been added to the new version of SNOMED? So very often you would see something like this, that the concepts can be understood in the receiving system, that it's there, because we have many concepts. So, and it is, even though we are adding a lot of new things all the time, it's likely that they will just be able to resolve it. But in a case, for example, as the example you see here, where you have like a pseudocyst of right ear, and we were forwarding that information, this concept was not present in the January 2021 version. So in that case, you need to review the latest version. They would know over here because they can see that it's the international edition. They know what version it is. They know what version to get access to be able to derive this meaning. So either they will have to update their system, or they would need to go to some public or shared place to find out what it means. This is just a view from the browser where we look at this concept. So when you are under the history tab of a concept, you can see the history of a concept, and for pseudocyst of right ear, you can see that it was added in May 2022, which is why the receiving system can't see it here. But this version, my point actually, I'll just go back. No, the point is that version will actually help you to understand why can't I interpret that code? I know it's SNOMED. I see nothing when I look in our terminology server. Well, the version will help you to say, this is why, and also help you where to look. Another example is when we have an older data that is captured using an older version, forwarded to someone using a newer version of SNOMED. So in this case, it's the same. They can see, okay, they have used an older version, and they can feel relieved because they know SNOMED supports full traceability, so they can just go back in history and see the state of a concept. But they know that because they are using a version, there may still be differences, because it can be that, or maybe that a concept has been inactivated. So in that case, they know, because they know the version, they know that it may be inactivated, but they also know that they can figure out where, or there are methods where they can figure out what the concept meant. And that is the case that we have here, where we have dermatosis resulting from immunosuppressive therapy. That is inactive in the September 2023 version of SNOMED. But as I said, they can be relaxed in the receiving organization, because they can look up the content details in the earlier version. And they can also, if they need to be able to process it, they can also replace that with, not replace, you should never replace in a clinical record, but they may also want to do any processing using the newer replacement in using the historical association reference sets. They can find what are the active alternatives to this. Just a view from the browser again. If you look up you have to toggle in the browser to look up both active and inactive concepts. And then you'll see when you search for a concept identifier, if it's inactive, it will show as pink, as you see it here. But when you go into the ref sets tab, you can see the reason why the concept was made inactive. So this concept was made inactive because it was non-conformance to editorial policy. And there's a proposed replacement to use this concept instead. And those replacements will be active. So if this concept at one point is becoming active, this row, this old inactivated concept will then refer to the new concept that is then active. So you will always be able to link concepts that have been inactivated to something that is active in SNOMED, so that you can look at how it sits in the hierarchy in newer versions. Some recommendations about sharing between versions. The overall recommendation is that if you have a shared model, also have a specify what is the shared version of the terminology resources that we use. So use that as part of your messaging protocol to also specify what version you're using. So ensure that all stakeholders that are involved in communication have access to the version. So in the case where you have different versions that are applied, and the risk of that you can't find the concepts, you should have like a common place that you can go and find the version. So have a place that is always kept up to date, so that you can always go back and look. That's, for example, similar to the public browser, the SNOMED browser, something common in that environment where you're sharing information, where you have the ability to go and resolve any issues. So now we move on to editions, because this is about, and all these principles also relate to versioned editions. So, but now we are communicating between across borders, in this case, country borders. So it may be that we have captured information using the Netherlands edition of SNOMED, and they are communicating with someone in Sweden, and in Sweden they use the Swedish edition of SNOMED. And this is where what we said earlier with the URI is quite important. So in the examples that you have seen in the previous slides, we have just used SNOMED.info /SNOMED-CT. So the very short, the first part of this. But now you see that we have a namespace identifier afterwards here. And that is what refers to that edition, the country's editions. So now, when we are communicating our information here, this is where up here, we should have added the URI for the Netherlands edition instead of just in the version. So up here, you would have the Netherlands edition. I apologize for that. We'll update the slides afterwards. But here, we would have the Netherlands edition. So it's not only the version. It can also be derived from there, but the best practice principles is to put it up there on the system to tell what the edition it comes from. And in this case, they couldn't find, I tried to do a lookup of a concept that is available in the Netherlands edition. So if we just go back. So this multiple liver system with this identifier here. If we communicate that with a system in Sweden. So I went to the browser and I looked at the Swedish edition and I tried to look up this concept. And you can see the concept could not be found in the Swedish edition. It makes sense because it belongs to the Netherlands edition, so it shouldn't be available in the Swedish edition. So what do you do then? Well, again, similar with the version, you should specify a version edition that is like your common reference. It could be the international edition. That's quite a good proposal because the international edition is there to specify what we internationally agree on and the information we want to share internationally. And the option is that the sender exchange both the local concept, because, for example, as you know in the browser, you can actually go in and look at concepts that have been added in different extensions. So the recommendation is to send the local concept and also send the nearest international concept. So that will lack the specificity because you would take, what is it? Often these extension concepts may be very specific leaf nodes that you have in the hierarchy, but then lack the specificity and then choose the most specific international concept that is available. That is a way that you ensure that the receiver will understand what this is about, but they will also see that the code that was recorded was something more specific. Yeah, and then again, you can set up a server across the sharing or the organizations that share information so that you can go in and resolve. And that comes down to when we talk about translations, whether it's a good idea for all concepts that you add in an extension, maybe to also have an English term for that. So that is something that is often discussed when you translate or when you create extension concepts. Do you need an English term? Or yeah, and if you know that the content is never going to be exchanged, maybe not. But if it's something that is bound to be shared and you would need to be understood in another system, then yes. Otherwise, the defining properties, where you would probably define your extension concept using the attributes that refer to international concept, will help the receiver to also understand the meaning of the very specific concept if the term is not in the native language of the receiver. And now I'll hand over to Alejandro to talk about the yellow box, sharing information model pieces.
For sure. That's so much.
I have a question on sharing two post-coordinated expression, and you have three approaches. I have question on second approach. So you have focus concept and then you have a body side, but you're not really saying whether that's a finding side or procedure side.
Thank you for that. No, but the fire resource that were communicated there is the condition resource. So, and you can then say, well, because it's a condition, you know, the thing that is recorded is a condition that makes the body side. So in that's why you don't send the attribute, because when you work with the information model give you that context. So if you are forwarding a procedure, you would use the procedure resource. And because that's a procedure resource, you then know the semantics of the body side, the relation between the code and the body side. Yeah.
And we have another question from the group. Is there a way, or is there any way or any metadata that hints if the code property contains a single code or an expression? This is when sending the expression in the code property. If you send the whole expression of the code property, that if you find any character that is not a number, you need to assume it's an expression, because otherwise you would see only a number. If you find a space or a colon or equals, and then you need to validate that text to see if it's real expression or if it's an error. Sometimes you may receive an error content.
I don't, yeah, I'm actually, I can't fully say if there, I don't know if there are specific metadata tags in Fire
No.
that allows you to say whether something is pre-coordinated or post-coordination.
No.
So no,
And even
I'm not sure.
yes, and the simplest a single concept is almost also a valid expression, because an expression is it starts with a single concept and you can add more things. So if we treat it as an expression always and you validate it, that will give you a hint about that. Thank you. And the main takeaway of all this is that if you do real interoperability in the real world, that you may have not be aligned with the version editions cross country, different cross border, different editions and everything, you require some processing. It's not that simple as you receive the code and you just use the code and that's all, and we are also happy. There is some processing in the middle. Yes, either the sender needs to be concerned about that and try to facilitate the receiver by sending extra information, or maybe the receiver needs to try to see how the code that he has received needs to map to their system. Yes, because the goal of interoperability is not only to share information, but to use the information you receive in the same way as if it was recorded in your system. So you need to somehow transform what you have received in something that is intelligible for your system. And as Annie was saying, sometimes the code is not enough, or we need to work with other standards, and with so many examples. So we were just seeing the question about how you can share a post-coordinated expression separated into different fields in an information model. Let's dig a bit more into that, how we can share the information models and what are the use cases. So in this case, the message we are sharing between organizations is a complex message. It's not just a code, but a piece of information that has a logic inside. And usually you get context in these messages. Yes, there are properties that represent things that are additional to the concept you are sharing. For example, you may have a code for the disease, breast cancer, that is saved into a box in the system A, that is the family history box. In the system B, you have family history of breast cancer as a diagnosis. Yes, and the system C, you have two things. You have breast cancer and person in the family because it has a special information model that stores the information in two fields instead of one. So this is the context that is present in the original system. So at the moment you need to share, there should be a way in which you need to communicate this context, because if you don't communicate the context, there may be some confusions and errors in the transmission or in the interpretation. If I share a message with the breast cancer as family history without agreeing how I define that something is a family history, the receiver can falsely interpret that as if the patient has breast cancer instead of a member of the family. So it's very important to agree in this model. There needs to be a shared model. Sharing codes usually is not enough. And there are different standards for model. And we've been talking about FHIR because FHIR is more common in the projects that we work commonly, but there are many other countries in the world that use OpenEHR, for example. That's another architecture for information models. So once the sender and the receiver have agreed on a model, now they have more information. They don't not only get the code, but they only get the context around the code. So let's say we have these different UIs describing something like before. One has the problem and the body site and the status, and they have cancer breast suspected, and the other one has only a problem and the body site, no status, and they use a different code, suspected cancer, that contains information. And the other hospital has a single box and they just look for suspected breast cancer. So these all have equivalent meaning, but at the moment of transmitting that, we need to transmit that in a single way. And the single way is using these shared models. And the easiest way to have a shared model is to adopt a collection of shared models, either FHIR or OpenEHR. And in this case, we are looking at a FHIR resource, yes, that has all these values. And the goal is you need to understand your own model, what is being used in your organization, and map those into the resource. This is a condition resource. The condition has a verification status, has a code, and has a body site. And then in your system, you say, okay, if I'm going to share this information model, which is a condition resource in FHIR, I know that the field where I put the code goes to the code property in the condition. the field where I put the body part goes to the body side field in the condition. And the field where I put if it's suspected or not suspected, I put it into the verification status field of the conditions. These resources not only have the properties, but also have the terminology bindings for the properties, the acceptable values for each one of these properties. So when you communicate something like this, you're communicating more clearly, because even if you don't have this information separate, you can extract the necessary codes from the system. Let's say, for example, these are the different examples, yes, and in hospital A, maybe it's the easiest one to map to a file resource because it has the same level of detail. Everything is separated, so just put one thing in the other. But for hospital B, there is not that easy because suspected is concatenated into the code. So we need to extract that in some way. For hospital C, maybe it's the one that's more difficult. We need to extract two things, the body side and the verification status. But this is possible to do using the terminology. Yes, so if we use the finding context of the concept that is being selected, I can know it's suspected. Yes, and so I can extract the suspected part from the finding concept. Yes, and then I can replace the code using the associated finding, which is malignant neoplastic disease. And so I have the information inside the concept in the SNOMED definition that allows me to better map this situation with explicit context into a file resource. Yes, and then I communicate in a way that is agreed with others using the file resource. And in the same way, I put suspected there. Oh, and that's the actual disease, and the actual disease goes to the second field. And if I go to the actual disease, I have the finding site, and the finding site is equivalent to the body site. So this is showing how I can explore my situation concept to extract the values that will populate the common model that I'm sharing with someone else. Yes. And if you do this process, regardless of which strategy you use in your local system to structure your information, you achieve the same data set. So each one of these systems should be able to communicate information in the same way.
Yeah, and I think for if you go back, Alejandro,
Sorry, I think there's an error
and
there.
it's often the discussion. So what do we do with the code? Should we also normalize that so that it's just that we use the malignant neoplastic disease for all codes, and that is also an option. But somewhere in the message, the recommendation is that you also the code that was recorded when you entered the data should then also be forwarded, right? So if you have normalized the code there, so that it says, because you could do that, you could have malignant neoplastic disease
In the three of them.
yeah. But then also share the thing that was recorded at the point of data entry.
And this is usually part of the agreements. When you share something, it's very difficult to share something without any agreement with someone else. That's why we will go later to explain about information exchange frameworks. But usually in the frameworks, explain how you should resolve this thing, how it is expected to work. So this is the full file resource, for example, that built from all the different parts. But then we have different level of details also, that this is interesting to explore. When we talk about information model pieces, we have some that are static and some that are dynamic. And this is interesting. The static ones are prearranged pieces of information like family history, condition, medication requests, medication prescription. So they're orders. They have a set of fixed fields that will be used. Maybe in a country, those fields are changed, so they're adapted to the necessity of the country. But these are static pieces of information that are called file resources or OpenEHR archetypes. Yes, you know what are all the fields that have there. But sometimes you need to represent more dynamic things that are unique for a hospital, that are unique for a disease, unique for a program or something like that. And sometimes it's difficult to maintain the resources. Each time you create a new resource or maybe a new archetype, there's an outsourcing platform in which you need to make it. You need to have agreements. It's rather complex. But there are a few things that are more dynamic that allow you to combine the static pieces. So you have FHIR questionnaires or OpenEHR templates that allows you to say, okay, to transform, for example, like a question, say this is a condition that is related to this context, this is an order, this is a family history, this is a medication that the patient is taking, and you can represent all that into the same structure. And you can edit and you can add questions and you can add information into these dynamic models. So let's go a bit through that. First, let's see an example of a static information model. And let me click here. And this is the allergy demonstration. Maybe you saw this already many times. Sorry if we are repeating the same examples in different presentations, but this is very static. This is a resource that is called allergy intolerance, yes, in HL7 So allergy intolerance has all these properties. And in this example, the properties are exploded into a form, a clinical form that is understandable by a doctor. So this is saying, if we are going to share an allergy between us in order to understand all the aspects of that allergy, we need all these fields. So if I type here allergy to aspirin, yes, this will get the necessary information and start populating the field for me. It would say, what type is? It's an hypersensitivity. I have two options. It's an intolerance or a hypersensitivity. In this case, it's a hypersensitivity. And that this was automatic due to the location of allergy to aspirin in the hierarchy. The clinical status today is active. I have a verification status, which is presumed, and I have a medication. The type of allergy is a medication, type of substance. The substance that is producing the allergy, the causative agent, is aspirin, and I say this is low risk, yes? And let's say that the reaction that is being produced is an urticaria, and the severity is a moderate urticaria that was triggered by taking the substance via the oral route. Yes, and this is all the data that I have written here is now represented into this JSON object, which is the actual instance of the allergy intolerance resource. And this is a static. If you see an allergy intolerance around the world, is everything, every time will be the same. This is very useful for interpretability, it's great. But there are not forms like this for everything. And one example is the synoptic reporting that Scott and the synoptic reporting work group is working on. If you want to report about cancer, you have a different form for each type of cancer. So maybe you have 60 types of cancers, and maybe sometimes they decide to split one or the merge one. So creating pre-arranged resources for all of them is really difficult to agree all of them, to maintain them updated and things like that. So when you don't have a very specific static resource like the allergy, you can go and you can work on creating a questionnaire, for example, in FHIR, or a template in OpenEHR. And to do that, let's go back to I have the sharing thing. To do that, there are several tools that will allow you to do that. And one of them is completely free, and it's really interesting to use, and it's very mature, which is the National Library of Medicine Form Builder. Yes, if we open these, oh, what I don't have here are the examples, I think. So if you go here, you can create a questionnaire from scratch. Yes, you can say, let's start from scratch. And you say, this is my form for representing the preoperative assessment. Something like that. I'm sorry about the type as well. So you can go in here and you can start creating questions. Yes, and for each question you create, you can say, there's a question code. Yes, there's a question code. And then let's say the first question is gender. And then you can go to the browser and see how gender is represented in SNOMED. So you can say the code of the question will be an observable. So if you do gender, and then you see only active concepts, and we see only observable entities, we see that gender is the observable entity. So I can copy the code from here. And I go to the questionnaire and here. And I say that this is the code. The system is the SNOMED system. I will do only one, don't worry, it will not bore you. The city, yes, and this is gender, yes. And then you have a question. You can do pay, this is what is readable. Patients, also the Danish layout is not easy. Patient, patient gender. Oh, it's easy. This is for me. That's easy for all Danish people, but not for me. Patient gender. And then you have the options. Yes. So in this case, which type of question is this? This is a choice question. So there will be options. And for each choice, I can either use a list of concepts that I copy and paste from the browser, or I can use an ECL. So because this is completely integrated with a terminology server. So if I go the SNOMED answer value set, and I go back to gender, but I use finding and where the instead of observable, let's say female gender, or let's look for female only. Female is body structure, female finding here. Finding related to biological sex. Let's say we use this concept. And then we go to the NLM and we say that the values acceptable for this will be, and I'm creating a small subset here. It's a terminology I need. There. Yeah, only subtypes, you're right. That value is not a valid concept. And then I can add a new item to continue doing. But if I click in preview, yes, I say the patient gender, and I have all the genders here for me to select. And here I'm creating a new resource. It's no longer a static resource. I can add more fields, I can add more things, and I can create a very dynamic resource that can be transferred. And this is completely standard. The standard that this is basis is called the FHIR questionnaire and has a companion resource that is called FHIR questionnaire response. So you create the questionnaire, you share the questionnaire with someone in an EHR, they can render the questionnaire just like this, dynamically. They can capture the information with the doctor, and then the information is stored as a FHIR questionnaire response that has all the responses from the doctor. And you can store that information there when you exchange it. Or there is a protocol called SDC, Standard Data Capture, that will allow you to pre-populate information in the questionnaire or extract information from the questionnaire. So let's say that the questionnaire says, is a patient diabetic? And using that protocol, you can, when you render the dictionary, you can understand that this maybe is a candidate for pre-population. You look if the patient is diabetic, and if it is diabetic, you mark as a check automatically without asking the doctor. And then when you save, from the response, you can also configure which one of those responses can be exported as separate fields. So maybe some things that you enter in the questionnaire will end up in your problem list or in your medication list or in an order. Yeah, so the questionnaire is something that can be done in, can live in the middle of those things. And also, let's say, yeah. Yes, I was trying, and if you go to the, one of the problems managing questionnaires is the challenges for maintaining them. Yes, you create a question, you see I was copying and pasting codes, so I can make an error in one of these. And also maybe the question is perfect today, but then SNOMED inactivates a concept that I have referenced, and I have some of the questionnaires that Scott is creating for synoptic reporting have 70 questions with nesting, with conditions. This question appears if this one has this value. And if a concept is inactivated in the middle, you get lost and it's really difficult to identify. So we created this tool that allows you to upload a questionnaire, and this is an example, and this tool will scan the questionnaire and extract all the codes that are mentioned in the questionnaire. It's going to create a list. This is the carcinoma for the exocrine pancreas histopathology reporting form cancer that has 137 bindings. It's actually 177 codes mentioned in the bindings. If you have an ECL, you get only the codes that you mentioned in the ECL, not the ones that will be returning from the server. So when you have all that, you can check here, validate, and this will go through the terminology server one by one, checking if in the current edition, and you can select the edition here with date and everything. If in the current edition, this code is active, and if the term that is being used is the same that is mentioned in the questionnaire, and if there's an error, it would say that it's an unknown code and things like that. So this one in red means that I created an ECL using the code without using the text. So this is reminding me, this is the FSM. So you can check if it's actually, this is the one that you wanted, or if you maybe use a different code or something like that. And if one is inactive like this one, you can replace it with an active one using the historical associations. You can click here and have a new version of the questionnaire with that updated, and you can validate again. And this is all green now. Yeah, so this is.
Yeah, and you can actually, then you can save it and you can upload it to the NLM form, and then you could view it, all the different questions and render it in the NLM viewer.
Exactly. So if I go here, we do import from file, and I see the file there, open. You will delete everything, okay, good. And you edit the questions, and now you have all the questions from the pancreatic cancer questionnaire here. And if I do a preview, you see that this is much more detailed, yes, and you have much more options here. Each one of these options has the questions and the values mapped with SNOMED city. And also, if we go to the, oh, yes.
A quick question. The answer can be a SNOMED concept, and we could use ECL to provide a list of possible answers.
Yes. It can either be an extension of
That's
list.
very dynamic,
Yeah.
very. That's
Yeah.
very impressive.
You have like 3 options. Because you can put one by one the codes you want. Sometimes you want a very concise list, like 3 or 4, so you can paste it there. You can use an ECL and be completely dynamic with descendants of, or you can use a ref set. When you use a ref set, actually you will use an ECL as well, but the ECL will say member of this ref set. And then you update the ref set, and the ECL will bring different results.
Yeah, and we're getting requests from different countries, and right now quite a lot of focus are on national registers. How do we harmonize them, and this is really a great approach to take to use the standards, and it is really straightforward. It seems like the greatest challenge is to make people agree on this is the way to go, but it is a very easy approach to actually have a highly standardized approach to registers and questionnaires in general.
Yeah. And there's the same organization, the National Library of Medicine of the US, creates the form builder, which is open source. You can use this code into your own system locally and things like that, but also has the forms widget that will render the form. So if you are coding your own EHR, you can use the library from there to have the logic to render automatically the form in your EHR. And also they have this questionnaire app, which is a Smart on Fire app. And this is really interesting because if you have like a big vendor like Cerner or Epic or the big ones, that they do have support for importing Smart on Fire apps. Yes, so this is the way in which you can render a fire questionnaire into Epic, for example, by providing the Smart on Fire app that connects to this questionnaire, and that will connect with information in the medical record and the extraction and all that. So there are different ways in which you can go from creating the questionnaire just for exploration to actually implementing the questionnaire in front of the doctor.
Yeah, but if you have forms that needs to go out to many stakeholders in your country, or at least provide some guidance on, this is how we recommend from a national perspective that you could record this type of information. These are the questions, these are the bindings. Imagine that you have that in just a single JSON file, and they can go in and they can review it all. Maybe they have to make some adaptations in their own systems. That's okay, but you have like a generic, a way where you can distribute these resources, and hopefully they will just take them and implement them. But at least in this way, you have a concise way of representing these are the data elements, these are the bindings, and this is how we recommend you record this information.
We have a question online from Sidelco. Is there any way? Oh, no, this is the one already replied. Sorry. This was the old question. So let's maybe go back to the presentation. But yes, the goal here is that using dynamic information models, you have much more freedom to communicate information and context. So we went from something very simple that was communicating a code to now communicating a whole dynamic information model that can be interpreted and things like that. And this is basically the workflow that you usually see, that is, there's a form editor that creates a questionnaire. The questionnaire is then rendered in a clinical application using a Smart on Fire or any other tool. The doctor enters data, creates a Fire questionnaire response. Then it may go or not. You can save that straight in the clinical data repository, the questionnaire response, and you save it there. Or it can go through a data extraction process. And you can say there's a new diagnosis in the form, then I want to save it in my diagnosis list, not only in the form, and you extract data from there. And then you can exchange data from your repository. And finally, for the final section, some information that even if when you want to implement any of these advices, we say that you need to agree many times. And it's impossible to share information without some kind of framework that guides you about what are you using, what are the models, what are the terminologies. So health information exchange always requires agreements and coordinations. The standards are an important part of the agreements, really important. Without that, it will be impossible to share information. But also there are other security and privacy policies. The patient identification is really important, because even if you represent everything perfectly well, but you cannot link a patient with another, it's really difficult. So there are many more layers, but we are focusing on the standards layer. And usually these frameworks require some role of the government. There can be private frameworks between organizations, it's possible, but it's usually very difficult to scale without the role of the governments trying to define and enforcing and promoting, especially the adoption of health information exchange frameworks. Sometimes there are regional, national, or provincial HIE networks. So one organization that is called IHE, which is very similar to HIE, but it's different. The IHE is an organization that produces implementation guides, and this is really standard. It creates integration profiles that defines way of doing things, combining different standards, because we in the SNOMED propose some good practices, FHIR proposes some good practices, and then IHE combines everything for a particular use case, like identifying patients, sharing clinical records, and something like that, defining the APIs, the mechanisms, the workflows. So it's really interesting that usually governments and countries that define these frameworks usually look for these ready-made use case profiles that already describe all the interactions in one specific setting. One example of what a framework looks like, and the framework looks like this. It's usually you have standards. We saw many presentations from countries today that are going through this process. Usually you can use the same terminology for all your codifications, for example, or sometimes you have different terminologies for domains. Use something for medication, something for diagnosis, something else for procedures. It's important to differentiate what you use for clinical coding and what you use for statistics. In this case, it's common to use SNOMED for clinical coding for the detail and the ability to do good analytics. But sometimes you still need to share ICD-10 codes for population-based public health, that maintains the history for many, many years of information collecting and the reports and the groupings, the logical grouping for public health, which is really good. Usually, these frameworks also define what to do with billing, the financial part of health, how these vocabularies and its standards are mapped to billing vocabulary. Sometimes billing uses the same clinical or statistical vocabulary. Sometimes they use something else. And this is usually resolved by mappings that are resolved by the organizations that present these frameworks. They also need to say what we will do with the information model standards, which is everything we have been discussing today, how to use FHIR or OpenEHR, which resources we will use, how we will use them, in which way. And then when we need to describe some processes like patient identification or document exchange, these frameworks can refer to something like HIE XDS, which is cross-domain document exchange, which is, if you read, it's a document that says you use SNOMED in this way, you use FHIR in this way, and all the actors that participate in a document exchange are these, and the actions required for this to happen are these, and this is the typical workflow. So this provides like a template for someone to create an effective exchange of documents. And of course, there are other layers like security and things like that. And usually the HIE frameworks require to define some kind of architecture. Yes. The most common one is to have some kind of exchange platform. Yes. So countries have different hospitals and the hospitals communicate with exchange platform. And this is the hub or the bus that communicates everything with everything. So if I'm in a hospital, I only need to connect to the platform and I will have a view of the whole system automatically. It's one effort I need to make. And this is usually the desired approach. And unless this is a big problem, most people go that way. It's possible to have complete freedom and say, let's put the standards and then anyone can talk to anyone. But that's much more difficult to enforce because if two hospitals start sharing information in some way and other two in a different way, then start competing to which standard they should use. Each hospital needs to integrate with many points instead of integrating with a single one. So this is much more difficult to manage, but maybe in some hospitals or some countries or regions, this is necessary because of the political structure of the health system. But it's usually having a centralized platform is much simpler. So in summary, for an effective and quality health information exchange, you need all these, everything that we have been describing today since the beginning. You need standards, you need to adopt the standards well, you need to be able to adapt the standards to your country, to extend them, to map them. You need someone who promotes how to use this standard, who has guides and has some incentives, maybe financial incentives for people to adopt them. And then you need to have these exchange platforms that will usually enforce that you're using the standard right. Because if I need to submit my resources to an exchange platform, they will validate it. So maybe if I do something wrong, the exchange platform will say, no, this is a wrong document. You cannot share it. So I need to be very clear and very careful to create everything in the right way. So we reach the moment of questions. No, it's the same one. No, that will.
Can you go back to information model for, I think it was a family history?
Yeah.
That you have 3 different models?
This one.
Yeah. So in case for the hospital A, it is very crystal clear. But for hospital B and C, there is a duplication of information. So would that be okay?
Yeah, suspected and suspected. Yeah, that's part of the framework to decide. In this case, in the example, it was decided to maintain the original code in the first field. But maybe the framework says, no, in the first field, I want the clean code, the most basic code. And it's completely possible to do one or the other because the information is there in the SNOMED representation. But it's a matter of policy, actually, which one you use. But yes,
Yeah.
here there is a bit of.
I think next time we
Duplication.
should add a slide where we have cancer. It's
In the
listed
3 of them.
cancer in all the
Yeah.
above, because from suspected cancer, you can go in and look at the the finding, the associated finding, and then derived cancer as
Yeah.
being
Yeah.
the code. And the same for suspected breast cancer, you go in and see
Yes.
the
And you get
associated
cancer.
finding.
Yeah.
Yeah,
So you
yeah.
can, and that's also what I meant when I said that you can normalize that code
Right,
using the
right.
defining properties of the situations. Yeah.
So do you do normalize?
You can say that we normalized the bottom two data elements, and we haven't normalized the first one. And whether or not to do it generally, that is where you need to make a decision.
It's a matter of
in-
preference.
in part of
yeah.
it. Yeah, part of that data exchange framework.
Yeah, if you are in a country, probably someone will have made a decision already and you need to comply to that decision. Yeah.
But my point before was that if you do normalize it and you exchange cancer in all of them, but you actually documented suspected breast cancer and suspected cancer, those codes that were recorded should also be included. So
As a
that you can
separate
go
thing.
back and see what was it that was recorded, what was that the clinician selected when they documented this.
Yeah, I guess for human users,
Yeah,
duplication is better than, but for the machine.
yeah, I agree. I agree.
normalize.
I agree. I agree.
Thank you.
For analytics and something.
There are other questions? Anyone online?
No,
Well,
no questions
no.
online.
You know what? Then we'll give you 10 minutes back of your time. It's been a long day with great sessions. So I hope that you will enjoy your evening, and I hope we see you at the networking session, I'll say, networking thing downstairs in a moment. And to those of you online, thank you for joining, and we hope you enjoyed it. Please reach out to us, and that goes for you too. If you have any questions or come to think of anything or need us to show you something again or anything. Thank you very much for coming.
Thank you.